Hey all dear students, welcome to the Quantum Guru. Let's see this question of electrostatics from Pathfinder. Check your understanding. Question number 8. So question is saying a uniformly charged right angle triangular lamina ABC shown in the figure. The acute angle at the vertex is theta. Potentials of the vertices A and B are VA and VB respectively. So we have to find the potential of the vertex C. So I'll solve it using the symmetry arguments. So here is the diagram. If I want to write potential at any point, so I can think of potential as something like some constant. That constant is a C into charge divided by length. So potential is of this dimension, and use that C could be some other constant into K, that is 1 over 4 pi epsilon naught. If I think about this lamina, the charge would be surface charge density sigma into area. Area would be again this length square. I can take any two lengths like this length or this length. So if I think of this length to be A, so this thing BC would be A sine theta and AC would be A cos theta. So obviously theta is fixed, so the BC and AC are also function of A. So the charge would be sigma into area. So for area I am writing length square and divided by the length. So sigma into C can be absorbed into C itself, so I can write C, or I can write some other constant, say K, not that K 1 over 4 pi epsilon, just constant. So this is K into some length. So if I want to write potential at A, so for potential at A, this K would be say different, and for the length I am taking that length to be that A, because you can take this length also, but no problem, that sine theta will be absorbed in this constant, or if you can take this length, then cos theta will be absorbed in this constant, because obviously theta is constant. If I want to write potential at A, so for that potential K would be different. So potential at A VA is I am writing say KA, or simply K1 into that A, and potential at B I can write some other constant K2 into A. Now remember one thing. So when I am talking about potential at A, the constant is K1. K1 when angle at A is theta, and potential at B is K2. So I am using constant K2 when angle at that vertex is 90 minus theta. So I'll use that later also. Now I want to do one very simple thing. I just want to drop a perpendicular from here to AC. So that is AN. So this is theta, this is 90 minus theta, so this is also theta. So now this whole triangular lamina, right angle triangular lamina, is again divided into another two right angle triangular lamina, like these two. This is a triangular lamina ACN, and this is triangular lamina BCN. The same argument that I have applied on the original triangular lamina ACB, that will be applied on these two triangular lamina. After all, they are of the same shape. So if I want to write potential at C because of the triangular lamina ACN, so because of this triangular lamina, if I want to write potential at C, and suppose this lamina is 1 and this lamina is 2, so because of this lamina, potential at C is this. So once again, let me recall the original. This was the original lamina, and A was the hypotenuse. Then potential at A, where the angle is theta, was K1A, and potential at B, where the angle was 90 minus theta, was K2A. So now here this is the lamina, and I have to find potential at C. Angle here is 90 minus theta, so the constant will be K2 into the hypotenuse of this lamina, which is a sine theta. So VC1 would be K2 into how much? A cos theta, and K2 into A is a VB. So this is basically a VB cos theta. And similarly, because of triangle CNB, which is the lamina 2. So potential at C because of this triangular lamina here at this point where the angle is theta, at the vertex when the angle is theta, the constant of proportionality I am taking is K1. So that will be a K1 into hypotenuse of this lamina, and hypotenuse of this lamina is a sine theta. So K1 into a sine theta, and K1 is VA. So that is a VA sine theta. So I've got the potential at C because of the two lamina. So overall potential at the C because of both lamina, I mean because of that overall right angle triangle ACB, would be VC is equal to potential at C because of lamina 1 plus potential at C because of lamina 2. So that would be how much? VB cos theta plus VA sin theta. And that is our answer. Thank you.